Hello? Okay, good. Okay, so first of all, I'm very happy to be here. I'm glad I'm having a chance to come here to PLNOG and talk to all of you. I'm coming here from the United States. I did a conference in Berlin as well last week, so I'm really happy to be in Europe and at PLNOG to talk to you guys. So let me tell you a little bit about myself. I joined Akamai about 3 years ago, and I was working in the network infrastructure team, and I was working on a little piece of communications infrastructure in the Akamai network. And so the Akamai network is this big, globally distributed set of servers, delivering content to customers around the world. We're doing all this fantastic stuff, and there's all this infrastructure that sits there sort of in the middle, and is sort of trying to coordinate all of this fantastic stuff that's happening out there on the edge. But we need to somehow have a way of having our servers talk to each other, and it's all distributed systems, all kinds of fun stuff. And I found myself working on this little piece of communications infrastructure it's very important to the overall operation of the system. But what it really comes down to is like you're writing this little piece of software that goes on this server. And while this piece of software is running on every single server out there, it's really hard to sort of get an idea of how this little piece of software sort of works in the overall system. And so what I found was lacking at the time, sort of in the internal development infrastructure at Akamai, was the fact that I couldn't sort of put my little piece of infrastructure into the overall system. Like our facilities are doing that, or at the time were very, very limited. And so how do I, when I'm fixing a bug in my little network daemon, or I'm adding some new feature to my little network daemon, I was having a hard time seeing how is this change that I'm making, is this actually fixing the problem, or is it it was difficult to sort of see how it was fitting into the overall system. And so, I saw a lack of sort of realistic, test environments, that we could use. And so, a year or two later, I found myself in more of a generalist position, more of working on sort of the general platform software and sort of coordinating all of this. And so, I saw sort of an opportunity to, build something that's really going to help all the engineers at Akamai to do this, this thing that I was having this problem with eventually. Let's just talk a little bit about Akamai itself. Akamai is this huge global platform. We've got these numbers are actually a little bit old. I think it's more like 140,000 servers at this point, and these servers are distributed all over the world. All these different networks, all these different countries and cities, obviously, and plenty here in Europe. Our NOC team in Krakow can certainly attest to that. And so we're serving all this traffic. It often gets above 10 terabits per second and 10 million concurrent streams. And sort of at the height of this, when we're have big events, we're up to 15 to 30% of web traffic, and so that's pretty impressive. The fact that our servers can deliver all that bandwidth is something that's definitely something to behold. So that's Akamai. That's sort of the basics. So what I'm trying to do is I'm trying to figure out how we can get our platform software out there more quickly, with a smaller likelihood of disruption, and faster. Right? Akamai's motto is faster forward, and so I'm trying to live up to that motto. And so what our team does is, it was on the slide up there, but what we do is we have all these servers out here, and there's this suite of software that goes onto every single one of these. And it's difficult because we're trying to coordinate with all these other teams across the company that are building software on top of this. And so we want to sort of make our platform software do the right thing. And while it's working with all these other disparate networks that don't necessarily want to change the underlying software because they see that doing this can have some risk. So the basic strategy here is that we want to sort of change a little bit, how we're doing our testing and development here. And so we're trying to use the cloud here to help us. We're trying to make it so that our internal testing and development is using not just physical servers, but taking advantage of some of these great things that virtualization can give us to make our testing and development infrastructure more flexible and sort of better provide for the needs of Akamai testers and developers. Okay, so like I said, Akamai itself is a globally distributed cloud of physical servers. You saw sort of the numbers up there. And machines at Akamai are grouped into functional units, and they're called networks. And so we have edge networks, and these are the things that provide the services to end users. And so we have CDN services. That's a big part of what we do. We have object and file storage and analytics, and not listed up there. We do all kinds of things relating to security for our customers, to prevent them from getting the DDoS attacks, and sort of give them information about which customers are using their networks. All kinds of great stuff. But on the other side of that is the infrastructure. So these infrastructure networks, they're the ones that provide the services that allow these edge networks to function properly. And so it's providing things like distributed file transfer and communications and monitoring and reporting. And it's interesting because 15 years ago, when most of this stuff was developed, or at least sort of the earliest sort of incarnations of when many of these things were developed, we didn't have things like Nagios. We didn't have things like just all the wonderful open source software that's out there. And so we've got our own systems that do a lot of this stuff, and it's good because it gives us a nice competitive advantage, because I think that a lot of the stuff that we do have is a lot more interesting and scalable than some of the open source software out there. But on the other hand, it's a challenge because it's not standard in the sense that we can take plugins from the open source world and fit them into our infrastructure. So that's a challenge, but it's good in a way. And so another thing I want to mention is that Akamai, the networks at Akamai, they're different. The software that runs on a given network is different from the software that runs on another network, and the only real commonality between them is this platform software that my group works on. Well, I mean, that's not the only commonality, but let's see. All right. So every network here is running a different set of software, and this depends on the role of that network in the ecosystem. And like I was talking about before, we have this platform layer, and this is what the network specific software sits on top of, and so it's providing messaging, monitoring, file transfer, and the OS software. And so we're continuously developing this platform software. And we're continually getting feature requests from the networks, and they're running this software in I'd say a very performance intensive environment. We have our servers out there where they're under a lot of memory pressure, they're under a lot of CPU starvation. They have a lot of I/O coming into them, both disk and network I/O, and a lot of times we find that the testing that we do on the infrastructure networks for this platform software that we provide sometimes isn't sufficient. We don't see problems until this software actually gets into the stage of being tested by the edge networks. We provide in our infrastructure networks, we maintain these, we run these. But we provide, sort of our client software, to the edge network, and you can see that, while we have good control over this, and we were able to sort of, maintain and revise this, and we have a good understanding of how this part of it works on the infrastructure networks. On the edge networks, it's often different because we have a little less control over how it works, and so we often see very subtle problems out there on the edge networks that are unfortunately. It's difficult for us because it's the sort of thing that you don't ever see problems until it's difficult to test for, I think, is what I'm trying to communicate. We never see the problems until they're actually used in a realistic way. And you can use all the mock objects and fake objects you want and try to sort of do all of the fake out these interfaces in order to test this stuff as much as you want, but we really don't see realistic testing until we actually get the software out there on the edge. And like I said, on the edge, the scale is a lot larger. We're pushing the limits of the design itself of the software. We're pushing the limits of the operating system. We're pushing the limits of the hardware. And so we never see these problems until we get there. And so just in case it wasn't clear from this diagram, what we're talking about, this infra network, we're talking about multiple machines in here. We're talking about multiple machines in the edge networks, obviously. And we're talking about on the scale of, in here, we're on the scale of like thousands. And here we're on the scale of like hundreds of thousands or tens of thousands. And so obviously there are multiple edge networks. We've got different edge networks that sort of have different roles in the ecosystem. Okay, so let's talk a little bit about sort of what the state of a network. What does that actually mean? Because if we're trying to test something, we want to know about the state of it. We want to know if we're trying to build these test environments, we have to know how to produce this state. So the state of a network, it's the installed software and configuration, and so that's just sort of the binaries that are sitting on the machine, the scripts that are sitting on the machine, the static configuration, and so that's relatively easy to define, right? We have a package, we install it, it goes on the machine, we know how that works. It's actually a little more complicated than that, but I'll get into that. We also have what we call, dynamic configuration or metadata, and so this is actually network-wide state. It's state that sort of is shared between all the machines in a network, and so this is, in some sense, universally defined state. So it's well defined, but it's shared between all machines, and so that's something that's interesting, and we'll get into that. And we also sort of on a given machine, we also have this sort of persistent state that's different from the state of the installed software and configuration, in that like it doesn't, installing a machine or deploying the software on a machine sort of doesn't change the state. This is only, if you have a database or a set of files that maintain some state. And so as part of this, like often we find that we have to do what we call manual changes. And so this is something that, if there's a bug in the software that causes us to have to like do some manual step in order to get the software working correctly, that we don't feel it's necessary to delay a particular release for, we'll have to do something like this. Or if there's like some tweak that needs to be applied to a particular machine or a particular set of machines, this is something that's we don't track these sorts of things as well as we should have. That's a challenge for us. And so we find that like the state of a given machine or even a set of machines can sort of wander away, and to like make it so that the state of a network is not as well defined as it could be. And so that means that each network tends to sort of have built up state, that isn't well documented or defined. And this means that we have difficulty sort of defining the state of a network externally. Like the state of a network is the state of all the memory and all the machines and all the disks and all the machines, but if we had to start from scratch, it might be difficult for us to get back there. But luckily, because this is a big distributed system, it's not necessarily a risk for us. And so I want to introduce the concept of an Akamai instance. And so an Akamai instance is a set of networks that sort of that function together. And so I was talking about before the idea of an edge network and an infrastructure network. And so you have all of these different edge networks and infra networks that all work together, and they all serve some role, because they all are functional grouping. And you have a set of these that sort of work together, and sort of you can group these into a single unit called an Akamai instance. And so an example, sort of the quintessential example or the canonical example of an Akamai instance is the production instance of Akamai, the one that actually serves customers, and the one that we charge people dollars and cents for. But there are other examples of these too. Like we have a special Akamai instance that is just meant to serve our government customers, because they have different requirements in terms of audits and this sort of thing. It's not something I'm super familiar with, but I do know that we do have something like that. And we also have sort of mini instances of Akamai that we sort of sell to various network providers that sort of desire their own sort of Akamai content delivery network behind their firewall. Okay, so yeah, what I want to emphasize here is that, you know, an Akamai instance is very self-contained, and that it is capable of providing sort of the Akamai services independently of any other sort of supporting infrastructure. So that's how I'm sort of defining this, and so that's an important concept. And so, like I said, we have multiple of these instances in production. But we also have multiple of these instances in our QA and development environments. And so we find this necessary just because I was talking before how like we don't necessarily have realistic or very realistic environments, or at least not as much as we want to. Like that's partially true. We do have a small number of these environments, and so how many of these there are, you know, perhaps on the order of 10 or 20 or something. But I think we would have the desire to sort of have more of these. In fact, we do have the desire to sort of provide sort of as many of these as possible. I think the ideal situation is that we would have, you know, an Akamai instance for every single developer to do their development against, and an Akamai instance for, you know, somebody to run in their continuous integration environment to make sure that their changes are doing what they're supposed to. And so another thing to note is that we have a relatively small number of these Akamai instances internally, but just because there's so much complexity here in these instances that many of them are only in not a fully working state. It's like, you know, one team might have an instance that, you know, sort of implements their sort of corner in the world relatively well, but the other part of it isn't necessarily functioning in a realistic way. And we've run into problems because of situations like this. And so we find that like a given Akamai instance is only, internally at least, is only in a semi-working state because it requires so much expertise to sort of, you know, get these Akamai instances into a fully working state. Because the expertise for this that lives in many different areas of the company, and that's what we find is that it's difficult to sort of, you know, have a completely functioning and working Akamai instance internally. It's very expensive to maintain such a thing. Okay, so this is basically just an illustration of what I was just talking about. So production instance is on the order of 10 to the 5th machines. We have our SQA and development instances, and we're talking sort of on the order of, you know, 100 machines possibly in one of these. Although, you know, perhaps we'd like to really scale that up and have like a development or SQA instance that's, you know, on the order of a production size instance, right? Maybe we could use virtualization to do such a thing. It might be interesting. Okay, so I was talking before, we find that maintaining an Akamai instance is relatively labor intensive. When I say labor intensive, it's all relative, obviously. I don't know what the ratio is of sort of the number of engineers per server at Akamai, but we try to generally keep that ratio as low as possible because we want to scale up and we want to make it so that we're able to support, you know, this large number of servers without having to scale up the manpower, or at least as much as possible. But we still find that like even instances are labor intensive to manage. Like our production instance, we have a NOC, Network Operations Control Center or Command Center, I forget what they call it, where we have people that are, you know, monitoring the state of the network and, you know, trying to, you know, see what's wrong or if anything's wrong and make sure that the instance continues to operate in an optimal way. But this doesn't scale for, you know, doing such a thing in a testing or development environment. We'd like to be able to commoditize this in some sense. And when I say commoditize, what I mean is that we want to take away all of this expertise that's required to sort of maintain these different subsets of an Akamai instance. We want to make it so we don't need, you know, Joe's expertise over here for Joe's network and Bob's, you know, expertise over here for Bob's network. We don't have Joe's and Bob's network. We don't call it that, but we like to be able to not depend on an expert's expertise to be able to create these instances or maintain these instances. Okay. So it's possible that we could invent a way or develop a way to automatically bootstrap an Akamai instance from scratch. And in fact, we do have a subset of this functionality. But doing this to sort of its full extent, or developing this idea to its full extent, we find that to be we find it to be difficult just because of the complexity of the software involved. And it's something that has to be continually maintained just because every single network is changing its software constantly, and therefore these bootstrapping steps would continue to change, and would they continue to be updated as the network software changed. Maybe it's not a priority today, and so we'd quickly find ourselves getting to a state where we're not in the ideal state where we could build our entire instance from scratch. So what can we do here? Well, so we want to get into a state where we're able to commoditize an Akamai instance, and so perhaps it might be intensive in terms of time, potentially maybe not time, but it's not a person's time, but just physical time, and or CPU, RAM, disk intensive. But in some sense that's okay, because buying these resources, we can put down money, we can buy these resources, and we find that these things tend to be a lot cheaper than our engineers' time. And so we'd much rather be able to throw some amount of dollars and cents, disk RAM, CPU at a problem, rather than having to have an engineer spend time on this. And so we want to get to a state where we can create an Akamai instance, without this expert's magical special sauce, and just throw some money at it and just do it. So the solution is that we'll use virtualization to do this. We'll build up a working Akamai instance, we could start with our SQA group and build this up and have it working, and bring in all the experts and have them bring in their magical special sauce and build this thing and have it working, right? And so this is great. We have this working Akamai instance that does exactly what we want for our testing and development, and we do this all in using virtual machines that we've instantiated from our private cloud, and we can save the state of these virtual machines. We can copy the disks around or whatever and sort of make sure that they're all grouped together in the appropriate way, and then we can create a complete copy of this thing so that we can provide copies of this perfect well-managed Akamai instance as a service, right? And maybe our group would provide that as a service, and so we find this to be a very very powerful concept. Something that there's a need for this in Akamai, and I think this is the idea of doing this and providing these as a service is something that's quite powerful. And so the idea of using virtualization is that we can in our private cloud is that we have a nice customizable way to just create a set of machines that, and we can abstract away all of the physical hardware that's required. And the other idea is that we can, instead of trying to, as I mentioned before, trying to track all of this external state and manage that and try to put that into some other set of machines, we can now sort of just store this state internally within the machines themselves. And we can copy this, and so the state is the machine, right? Instead of having to store the state and try to get into a set of machines, we can just store the machines themselves. That's the state. That's where we want to be. Right, and so now we can abstractly copy these machines around. We're now abstractly copying the state around, and that's exactly the state we want to be in. So for cloning an Akamai instance, there were a couple of challenges. The way that our infrastructure is designed, we use static IPs for everything. We use static IPs to address machines, and to identify machines. And so if we're simply doing, using this idea of, cloning these images and moving them around, you're going to run into problems there with, if you're just doing this naively. Because obviously, your IP addresses are going to start to conflict with each other. So the idea is that you can use, isolation, network isolation to isolate these Akamai instances. And so that causes you, so every time you create, every time you copy an Akamai instance, well, now you have to have some sort of router that you're going to put this behind. Now you have to, you have this NAT, to allow the machines to possibly reach the outside. And you have to have, a method of addressing the machines inside this isolated network. And so, we've got a couple of solutions that we're using for this. And so the idea of traditional NAT is just that you're, I'm sure everybody here knows exactly how NAT works, I guess. And so the other idea is that you can sort of use a reverse NAT, potentially to reach important machines inside the instance from the outside. And then you can use socks and Auth Gate. Well, I'll talk about that. Let's see. All right. Okay, so this is sort of just like a demonstration of what I'm talking about. Like you'd have these two instances would look exactly the same. Like they know about their gateway at a certain IP address, and so you can copy these clouds of machines around arbitrarily. And from a client perspective, when he wants to reach instance A, all he has to do is say here, well, I know the IP address of instance A, so I can reach it via that. And instance B, that's 238.20, so that's great. And so the problem becomes is that we want to have a way of addressing the machines inside these instances. And so we have a couple of different means of doing that. I was talking about NAT, and so that's allowing you to send a network packet, a TCP connection or a UDP session or an ICMP packet to some host on the internet. That's not illustrated here. But the client also wants to be able to address machines inside these instances, right? And so he can reach the external IP address of the router here, but it's not as obvious about how he's going to reach inside this isolated network and address a machine inside here. So it's possible to use a NAT configuration to basically assign a given IP address on the external IP address to an internal IP address in here, and sort of NAT sort of works in the same way there, where you can address a machine like this, and it, the router has some state that it maintains that allows you to maintain a TCP session. You can also use socks, like if you can there are some command line tools that allow you to wrap the libc connection, like libc networking calls, like connect and send, and basically forward an arbitrary arbitrary program using socks, I guess. And so we've implemented that idea as well. And so the other idea is to use this thing that we call Auth Gate. And Auth Gate is just basically a drop-in replacement for SSH. And so a lot of our infrastructure depends on this. And so it's basically just an SSH forwarder. And so you create an SSH connection into this guy, and this guy in turn creates another SSH connection to a server within there. And so there's a nice protocol that we have that does this. But the important thing is that a lot of our infrastructure sort of depends on this. So just by putting this simple Auth Gate daemon on this forwarder, this gateway, we can sort of have a lot of our stuff just work. So I think that's the important thing. Yeah, so I've talked about sort of some of the nitty-gritty of how we're managing the network side of this, and sort of how we're using the idea of cloning virtual machines to create an Akamai instance. But we're using some open source private cloud infrastructure in order to sort of provide our virtual machines as a service, which is great. But we sort of found that we needed another level of management, beyond just like, well, here's a machine, here's an image, copy this. It makes things easy. But we want another level of manage in terms of how do I address an Akamai network within this instance, and how do I sort of treat these Akamai instances as a group, and there are different machine types in here, and we want to be able to sort of refer to these and sort of store data about these, and sort of use Akamai services in a kind of a generic way, and address these in a generic way. So we decided to see how we could do this. Let's see. So what we wanted to do is provide a very simple interface for providing an Akamai instance as a service. And we wanted to be able to say, well, you just give me one piece of information about which Akamai instance it is that you want to clone, and we'll provide that. It has to be a very simple thing, just because people aren't going to use it if it's not simple. And so once you sort of have, let's say like your handle to this instance that you've given somebody, they should be able to sort of derive all the information about what they want, what networks are there, what machines are there, what services are available, which gateway to use. That should all just fall out of that and be really transparent to the user. Yeah. And so the idea is here that we're going to provide an Akamai Instance service, and this is going to be, we want to make it service oriented, just because we don't want to have people to integrate with a library. Well, I'm not going to say that, but the nice thing about providing it as a service is that you can make this language and test harness agnostic. In this service, sort of the interface that we chose was using like a REST JSON web API, and it's turned out to work pretty nice. And the other idea of like making the service oriented is that you can share common resources across groups, I guess. And the idea is that the common resource, is often going to be this well-managed Akamai instance that I keep referring to. And so we want to say, okay, well, you can take your copy of this well-managed Akamai instance, and I can take mine, and we're all set. So here's sort of the kind of what this would look like. The user is going to say, oh, okay, give me an instance. Give me the instance that I know is really good and I can use to like do all my testing, and it's going to be perfect. The instance service says, okay, I know about this instance. I know what to do here. I'm going to clone, all of these machines, and so it also knows, well, I'm going to create this gateway, right? So he talks to the private cloud orchestrator, our private cloud, and creates these resources, clones them from the existing saved virtual machine state. He creates the new gateway. He tells the gateway, oh, you're going to have this external IP address, that's in our private IP pool. I'm sorry, our public private, I guess, within our internal network IP pool. And so the instance service says, okay, I've done all that stuff. Here's your instance, and so now the user can start using this thing. And this process of creating these resources, actually, the way that we've sort of arranged our private cloud infrastructure and stuff is this is actually a relatively fast operation. Like we're talking in the order of 5-10 seconds to create one of these things. And so that gives you sort of the freedom to create one of these pretty transiently. So it's like I could create one of these things, boot them up, maybe that takes another 15-30 seconds or something. Run some test, install some software, run a small test, and then throw it away, right? These are not necessarily like really long-lived, instances, and so that gives us a freedom to, really, run. Maybe if you wanted to run continuously and you had a test that just do one thing and just throw it away, it's possible with this. Okay. And so I was referring to before, we're trying to leverage expertise from around the company to create this internal master instance, of these virtual machines. And each initial network is going to get it closer to a real instance. And I think this is sort of speculating now because we're sort of not at this stage in our deployment yet, but the idea that you're going to start with a master instance and some group is going to take it cloned, and another group is going to take a clone from their clone, and these are going to start to diverge. It's an interesting idea, and I hope it does, sort of become, that successful, is where we have this idea that, like, one group is maintaining, their, perfect Akamai instance, and the other is maintaining their perfect Akamai instance, and it's like I, as a user, can start to pick and choose about the one that I think is best or the one that fits my needs the best. We hope that it does get to that point, but the idea is that, like, we'll have at least one, that's going to work well. Yeah, and so the idea is that we can bring more and more of our infrastructure into this fold, like this Akamai instance idea becomes more powerful. We're gonna, the idea of commoditizing this thing, we're only gonna need resources in order to build this. And so another interesting idea here is that the fact that we've now got this instance service that knows how to build these Akamai instances and clone them from scratch, or I'm sorry, clone them from other Akamai instances. And so at this point, we've sort of invented this interesting concept that we didn't really have a good concept of before, is that we have this means of referring to an Akamai instance where it's like we have some idea of what all of the state of this instance is, and we can manipulate it in various ways. And so the idea is that we can take some of our existing instances of physical machines that we have in our test networks and start to refer to them using this instance service. And so we have all of our existing lab test Akamai instances, and we have our Akamai production instance. There are a couple more of those actually. And so the fact that we can sort of start to refer to these instances using this instance service of not only these virtual machines that we've created using our private cloud, but referring to existing physical machines using this exact same interface. This turns out to be, I think, a nice concept for us. The fact that we can now refer and address, a physical instance and a virtual instance in exactly the same way. This allows us to, potentially write code that is testing, these virtual instances in a continuous and integrated way, and take that exact same code and run it against the production network, as long as we believe that whatever code we're writing isn't disruptive. And we've got all kinds of security restrictions that prevent us from doing anything too bad, but obviously we've got to be careful about that. But just the concept of being able to refer to an existing lab test instance is a powerful concept. How close? Okay, so I got about a few minutes left. So right now our unit testing we're doing lots of continuous integration with our unit testing, and we're doing some continuous integration with our dev QA, but where we're really missing it is in our SQA. And SQA, that means system quality assurance. And so what this Akamai instance virtualization concept allows us to do is to get closer to doing this continuous integration in system QA, and I think that's something that's really important to us. And checklisting here it's the step that we do when we're deploying a new software release, where we're checking that the service is functioning correctly for like the first phase of our deployment, which might just be a couple of machines, and then the next phase might be 3 or 4 more machines, and the next phase might be 100 machines, the next phase might be 1,000 machines, the next phase might be 10,000, 100,000. Every network's sort of got their own deployment, but you're doing these checklisting steps after each phase in order to make sure things are working correctly. The idea is that you can use this instance service concept even for the deployment network to sort of do some subset of the steps that you were doing dev QA and SQA during the checklisting phase. And so the idea is you're sharing some common code between some of these testing steps that you really weren't able to before. And this is allowed by this instance service concept. And the alerting thing is sort of another thing where we're continuously doing checks on the network, and one might say a continuously integrated way to make sure that things are functioning correctly. Yeah, okay, so I basically just said this. Yeah, we're going to unify these stages, and you use some of the same code to do this. Yeah. Yeah, great. Continuously integrated, everything is. Yeah. So the takeaway here is that we're trying to virtualize Akamai and provide this as an internal service. And for all the developers at Akamai that want to use this, I think that's a powerful concept. And that we're trying to simplify our testing using the power of the cloud. That's buzzword these days, but it really is an important thing to use, and it's be silly to ignore it. Thank you.
Dziękuję bardzo. Teraz zapraszam na wykład pana Piotra Szafrana. Tematem wykładu będzie teraz MPLS, ale jak przez 20 lat do tego dochodziliśmy. Chcę tylko przypomnieć, że jeżeli ktoś z państwa będzie miał ochotę zadać jakieś pytanie, proszę o podniesienie ręki i hostessa podejdzie z mikrofonem. Dziękuję.
Thank you.